Good morning, everyone, and welcome to session number 4, episode number 4. I hope you can all see the live stream at the moment. So I just want to make sure it's streaming properly. Yes, it should be. It should be live now. So do say hello. This is an interactive session, and we would love to hear from you. So do make use of the window. There is a chat window which you should find to the right of your screen. So anyway, I hope it's all going ahead properly. Sometimes there are some technical issues, but in most cases they can be resolved. Sometimes I have some internet interruptions, but I should be able to see any comments and make comments on a separate computer if there are any interruptions. Oh, there is Phil. Hi, Phil. Phil Schaffer, hello to you. Very good. So you can hear us. That is excellent. I'm great. It's great to have you here. So today we have a very, very exciting episode. Actually, you know what you can see at the moment is that the roof. Hi, Ed. Good morning to Ed. Good morning. Good to have you here. Very nice to see your comments. You could see it's raining at the moment, or the roof is closed, but it doesn't matter. We are going to go ahead anyway, because I think what we thought here at iTelescope is to give you consistent and hopefully inspiring and interesting materials for you to digest on a weekly basis. So we will keep to a schedule, and actually we've gone ahead and done the images yesterday and before yesterday, and we certainly don't want to delay that. So we will be streaming at regular intervals, and we will be announcing them accordingly. So what have we got today? As you can see, this is the way, for those of you who haven't seen what it looks like in New South Wales in Australia. This is iTelescope there on a sunny day. At the moment, as I said, the roofs are closed, but not to worry, we're going to go ahead. So let's jump straight in. This here, what you see here is, and you've seen this in previous episodes too, is just a 20 to 30 second exposure, which I took when I was in Australia, of the beautiful Milky Way we have there. And what we're going to explore today, and you'll see a red mark on the screen there. I'm just pointing the arrow so you can see it. Are two very strange neighbors that we have. One of them is called Centaurus A. You can see that's in the constellation of Centaurus, just to the right here, or to the west of the Milky Way. And the other one, also very interesting, is the Sombrero galaxy. And they are so interesting that it is really worth talking about these and saying quite a lot. So welcome anyway to episode number 4. So let me give you a little bit of background. We have become very used to the world around us. That is, things in our world behave the way, and they always behave the same way, in a consistent way, time and again. So when you throw a rock in the air, it'll come down and follow the path of a beautiful parabola before it hits the ground. And when you turn on the stove and you see the plate getting hot, we see it glow red, and know exactly that it is not a good idea to touch it. And then when there's a storm, we see lightning, and we wait in great anticipation for the loud bang, which we know to be thunder. This is all in our known universe, and we can go on and make long lists, and we seem to cope very well in it, and it has helped us make marvelous inventions. We understand them. And then what? What does understanding really mean? My physics professor simply said to me when I was a student, understanding is nothing else than getting used to things. Yes, used to things. We are used to the world around us. And when we shrink into the tiny world of the atom, our understanding is determined by strange behaviors of the quantum world, to which we are used to as it is now. But then there's another world, And that seems even stranger and more surprising, the large scale. So we are somewhere squashed between a small scale and a very large scale. Once we move beyond the size of our solar system, we encounter matter in the extreme high temperatures and pressures of stars and galaxies, resulting in monster stars that can violently explode into supernova. Neutron stars will come across them later, black holes and so on. And to our surprise, all the stars, planets, and galaxies that we see today make up just 4% of the universe. The other 96% is made of things we cannot see, detect, or even comprehend. And we call them really strange. We just call them dark matter and dark energy. So welcome to our episode of Strange Neighbors in the South. And then let's jump straight in. So our first object, and that is really interesting, let me just get rid of the arrow here, is in the constellation of Centaurus. I'm just showing you that Centaurus is just to the west of the Milky Way, and the picture that I've just shown you, and it is very close indeed. It's only 12 million light years. So whatever you see there has happened 12 million years ago. That's actually very short on the scale of the universe. And then you may ask yourself, well, how many neighbors do we have in a vicinity of 12 million years? It's actually very few, because Andromeda is the really first biggest galaxy that we know in our neighborhood, which is about 2.5 million light years away. And in a radius of about 15 million light years, you would probably find a dozen large galaxies and approximately 100 or so dwarf galaxies. So you can imagine that these objects are very, very well studied by astronomers, because we are caught in our own spiral galaxy looking or trying to look in or outward, and we can only see a small portion of the 100 billion stars in our own galaxy, because most of our views are obscured by interstellar dust. So what we do is we look outward, and by looking outward is just like looking in the mirror or looking at our friends, we gain understanding of our own behavior and who we really are. And that is why we explore the other neighbors nearby. Now, what is interesting about Centaurus is it is really, really weird. And I will show you some images to explain. So this was taken with, this is a 5-minute, 300-second exposure. I'm just going to jump now to the other screen to show you which telescope that was. Let's see if I can get this online quickly. So where is it? Yes, there it is. There it is. That is T30. So this is a plane wave. That's a large reflector, about 0.5 meter in diameter. And yesterday I did a 5-minute exposure with that, 300 seconds. And the resulting image that you see is this. Okay, so isn't that strange? So let's have a look at this picture. So this object, as we just mentioned, is about 12 million light years away. The size, the apparent size, we talk about apparent size in the sky, is just a little smaller than the full moon, which is quite surprising. The full moon has an apparent size of about 0.5 degree. So this is a little bit smaller than 0.5 degree, and it really is weird. I remember so well when I was in South Africa for the first time in 2000, looking at the night sky, and I had a very simple equipment at that time. This object made me completely stunned. And let's take a closer look at it. I'm going to get my arrow in here. So at first, it doesn't appear unusual in any way, because it looks very much like an elliptical galaxy. Okay, elliptical galaxies are galaxies that have no apparent structure of any interstellar dust. They contain all those stars. We have lots of elliptical galaxies, as opposed to spiral galaxies. Spiral barred galaxies are galaxies in which we in which we live ourselves. But then there's really something weird. We take a closer look and look what we see in the middle. That is really obscure. We suddenly see a very thick band of interstellar dust there. That is strikingly strange. Not only that, but it seems to be bent in a very, very strange and obscure way. So this indicates that something has happened to this galaxy, which is 12 million light years away. So whatever's happened has happened about 12 million light years away. The size of this galaxy is approximately 60,000 light years across. So our own Milky Way has about a diameter of 100,000 light years. This is about 60,000 light years. Okay, so it really is peculiar. So it's a mixture. It seems to be a peculiar galaxy, and that's also what it's called. It is some type of mixture between an elliptical and a spiral galaxy, and it does indicate that something violent has happened. The name is already very telling because it is called Centaurus A. Centaurus A means that that it has major significance in the constellation of Centaurus, and it is actually a name of a radio galaxy, and we'll get right to it. So let's take a closer look at this. And the interesting question: what may have caused this very strange-looking galaxy? And let's go to the next image. So this is a closer look now. This is a closer look, and you can clearly see the structure of the interstellar dust here. It's very, very thick. And then we're going to take an even closer look, and this is my friend Josep, whom you've met before. Josep is a brilliant, he uses iTelescope a lot, and he actually produced this image yesterday, which is fantastic. That's also why I was happy that this was delayed. But you can see he's done an RGB, a red, green, blue, and luminance image of Centaurus A, and already the structure becomes a lot clearer, because what you can see now, and this is very unusual for an elliptical galaxy, is you can see some blue, very faint blue stars there, which indicate that these are young stars that are born in the interstellar dust. So this interstellar dust seems to be very, very vibrant, filled with hydrogen and other interstellar gas that, when illuminated properly, will create new stars. So that's the first thing we see. And then let's take a closer look. It gets really interesting. So when we zoom into his image, and this is remarkable what you can actually do with telescopes nowadays, we find something really, really remarkable. Look at the band there. And now this doesn't look very nice as an aesthetic image, but I am using this as a scientific image. So what I've done is I've enhanced the contrast to really look at the fine structure here of the halo that surrounds the galaxy. And you can see there's a very clear band here. And indeed what this band is, it looks like a shock wave that has occurred when two galaxies collided. And it is amazing that you can actually see this, because this appears a lot in scientific reports. This is a band that has a length of approximately 10 to 12 light years and is again filled with blue stars. That means new young stars are born here. So this violent collision that Centaurus A has experienced is indeed the birth center for new stars, and it is incredibly interesting for astronomers to study it. And it is really remarkable that we can see it here on his image very, very clearly, that these bands of new stars appear. So, of course, it gets more interesting then if we zoom in with the Hubble telescope, which of course has a much better resolution, and indeed this confirms, you can see all these red centers there, which are birth centers for new stars. These are typically hydrogen alpha images that are superimposed, and you can see that. But it gets even more crazy. As you know, we only see a very small part of the sky, of the visible of all the electromagnetic waves. We only see from approximately from the very, very dark blue, which is somewhere around 400 nanometers, to about 700 nanometers, which is dark red. But it gets much, much more interesting when you look at radio waves. And this completely shocked me, this picture. I could not believe it. Now think about this very carefully. Centaurus A is 12 million light years away. And if you look at the radio signals, so we're looking at long frequencies, much longer wavelengths here, much longer wavelengths in the gigahertz range or so, you will find that Centaurus A in the radio spectrum is, and that is shown here in purple, is emitting a huge radio source which covers about 8 degrees of the sky. Now this is an absolute shock. 8 degrees of the sky. This is 12 million light years away, and is stretching. You can see the moon in comparison. The moon is covering about half a degree, and here, in comparison, you can see the radio telescopes. This is covering 8 degrees of the sky. Now, this is an absolute shock. This must mean that something very, very violent is going on up there. 8 degrees of the sky at a distance of 12 million light years is absolutely stunning. This is the apparent size that we're seeing. I mean, I had to look at this image a few times to actually believe this, because it is absolutely stunning. And it gets really crazy because when you look at different wavelengths, and that's the advantage they have, they look at X-rays, they look at infrared, they look at radio waves. If you look at the infrared picture of Centaurus A, it looks even weirder. It's weirder than the weirdest science fiction book, because at the center is a type of parallelogram, or you call it trapezium, a parallelogram, and that again indicates that there must have been a violent collision going on. And it gets even more crazy then when you go to the X-ray spectrum, because if you go to the X-rays, you will find out that there is a huge jet emerging from what we call the accretion disk. Okay, you can see that it covers several light years and is actually very, very consistent with the radio source that I showed you earlier. So it is a huge ray, and it is believed that this ray, this huge jet, and it really comes like almost like a light, like a laser beam stretching over many light years, is caused by a supermassive black hole in the center of Centaurus A. Now, how do they know that? Well, they know that because they measure the rotational speed of stars close to the center, and they look at the whole behavior of Centaurus A, and it gets very, very hot. It is similar to a bathtub. Imagine your bathtub, and the water sort of swirls in one direction into your bath. The same happens. The stars and all the matter very, very close to this supermassive hole gets so hot, and it causes a massive magnetic field. And this magnetic field then causes a very fine beam of superheated plasma streaming seemingly out of the center of that black hole. Of course, black holes don't emit light. This is what happens through the rotation of the accretion disk. And this is very, very much still in the beginning of all this research, but all this is part of this amazing galaxy called Centaurus A, which I will show you once again here. That is Centaurus A. That is the image we've just been looking at. So very, very stunning, very puzzling, and subject to a lot of research. So I hope you found that interesting. I certainly found it absolutely stunning. So if you have any questions or so, just jump in. You're always welcome to ask. I really would like this to be interactive, and I'll do my best to answer. Okay, next one. Let's go on to our final object, and that is the Sombrero galaxy. The Sombrero galaxy is also very, very fascinating because it is much further, but it is a very, very popular object by amateur astronomers. And the Sombrero galaxy, let me just, 1 second, I must just move this correct here. Got something on the screen here. Just give me a sec. Okay, there we go. So the Sombrero galaxy is about 25 million light years away. And it's an interesting question. How did they know how many millions of light years that is? That is a separate topic. But it's in the constellation of Virgo. And what is remarkable about this this galaxy really, and that I'll show you in the next image. Sorry, not this image. This image here. That's the one I meant to show you. Is that it really looks like a Mexican hat. It looks like a Mexican hat. You can see it's on the side. And it's got this incredible halo, overwhelmingly bright center. Okay, so what is the Sombrero galaxy? It's one of the most unusually looking barred spiral galaxy visible from Earth. It has a bright nucleus, large central bulge, and spiral arms threaded through with a thick dust lane, and that makes it look like a hat from Mexico. Okay, that's what's remarkable. So if we zoom in, and this is again taken with the same telescope that I showed earlier, we zoom in, you can clearly see the dust lane, and you can see it's remarkable. It's an edge-on galaxy that is almost perpendicular to our plane. It's very, very interesting. It's almost 90 degrees, and we can just see a little bit of the structure if you look carefully. You can see the dust lane here, of course, but if we resolved this and we took more images, we would indeed see that this is a spiral galaxy because you can see the dust a lot better. Indeed, again, if you go in with a Hubble telescope, and they just turned it 90 degrees, there's no up and down in space, you can see the very, very thick dust layers here surrounding it. And you can see what is also remarkable is this incredible halo. Look at this incredible halo. And what is remarkable about this is galaxies in general have globular clusters. Our own Milky Way is known to have about 150 globular clusters approximately. We can't see all of them, but those that we see are about 150. And globular clusters, as I mentioned in an earlier episode, are balls of stars, very, very tightly packed, and they are almost spherical, and they are very, very old. They are known to be one of the oldest objects in the universe, some of them much older than our own galaxy, and they probably played a big role in the formation and the history of our galaxy. And what they found is that where the halo is very strong, right in the center, that's where you find most of the globular clusters. Now, what is remarkable about Sombrero galaxy is that these globular clusters are very numerous. There are about 2,500 globular clusters in the Sombrero galaxy, which of course is very interesting for studying. So again, the Sombrero galaxy is similar size to our own galaxy. It's approximately 80,000 light years across, but it contains a lot of globular clusters. So rather interesting. And as you can imagine, this has been subject to a lot of scientific research. It is still a big question. You can see a lot of the very, very thick dust in the Sombrero galaxy, which indicates, again, that there must be a lot of hydrogen gas, and these are centers for birth of many, many new stars. That is the function mainly of the interstellar dust, which, by the way, as I said before, are very, very present in spiral galaxies, but almost absent in elliptical galaxies. Only if you get a crazy galaxy like the one that we've seen before, that is a mixture between an elliptical galaxy and a spiral galaxy, such as Centaurus A, then you get this crazy distorted view, which probably was a collision. But also the Sombrero galaxy, by the way, is very interesting because it probably contains. How do you differentiate globular cluster from superimposed? That's a great question, Phil. That's a great question. So globular clusters, the nearby globular clusters can be resolved with large telescopes. Globular clusters are characterized by stars of very similar age. And some of these globular clusters indeed could be hidden by galaxies, and you're absolutely right. We don't know, for example, what is behind the Sombrero galaxy, so some of them could be obscured. But the Sombrero galaxy is close enough that with a large telescope you can indeed resolve globular clusters and you can count them. Otherwise it wouldn't be possible. So they recognize globular clusters by looking at the spectral characteristics of stars and comparing them. And if they're very similar, then these are typically globular clusters because they're very, very old. I hope that answers it. But if you go further out into space, you cannot resolve globular clusters anymore. They're simply too small to see. You can only see galaxies. And the further we go back in time, or the further we go and explore the universe, you eventually only see dots, and these dots that look like stars are all galaxies. So you're right. That's why the immediate vicinity, and that is possibly within 20, 30, 50 million light years, which we call our close neighbors, are the most interesting for for astronomers. Phil says, I'm stunned that we can get spectra. Yes, this is a very interesting point you're making there, Phil, because I love spectroscopy. That is also my background, not so much the astronomical spectroscopy, but spectroscopy as such. I did my master's thesis in spectroscopy of supercritical mercury vapor, which was very interesting. And you're absolutely right. Everything almost that we have learned so far, and now we're expanding very much, has come through the things that we see. If we were living on Venus, where there's always cloud cover, we wouldn't be able to see anything. We would always have cloud cover, and we may never have known that there is such a thing as a universe, unless we would have had rockets that we could have gone beyond the cloud cover. Our fortune was that we can indeed examine the light, and as you correctly said, it is amazing. We look at the infrared spectrum, we look at radio waves, we look at the visible, we look at the X-rays, and all these different spectra give us incredible information about the distance, the speed, the rotation, the size, and so on. So you're absolutely right. It gives amazing information. And the interesting thing, Phil, about all this is that the behavior in the universe seems to be the same everywhere. So whatever you do in your room, the way light behaves is very similar to wherever you are in the universe. That at least is the assumption of science. Okay, so very, very good point. Okay, so good point on that, and that actually brings this session to an end. Again, the Sombrero galaxy is very interesting because there's a supermassive black hole in the center, and it's known to be a lot bigger than our own black hole, which is our Milky Way. They can estimate the sizes again by looking at the total mass, the luminosity. They measure the total luminosity of a galaxy and can thereby infer the size of the black hole that is keeping all this galaxy together. Really stunning objects we have up there. So that's about it for today. I hope you enjoyed this session. I will be back next Saturday, and we will go on a regular basis. I will also be in Australia from about 19th, 20th of April, and I will be there for 2 weeks, and will be broadcasting live also from iTelescope. In fact, that's something to really look forward to. So I'll be broadcasting both here on this channel and possibly on Periscope or YouTube and other ways. So you'll be seeing a lot of me between the 20th of April and the 4th of May when I return. Anyway, thank you, my friends. Thank you, my Astro friends, for joining. I hope you enjoyed this, and take care. I'll see you soon again. Thank you.